Hello to everyone. I'm very happy to attend this conference finally for the first time. I work at the Faculty of Graphic Arts, and I will present you work that I did with my colleagues Rahela Kulčar, Marina, Vukoje, and my student Petra, Širol. Let's make a short introduction. Thermochromic inks are temperature-dependent materials that change color due to temperature change. Currently, they come in two forms, liquid crystals and leucodyes. Leucodye-based inks are being used more often, especially in smart packaging applications, as, for example, temperature indicators. Regarding the color change, they can go from colorful to colorless or colorless to colorful, or can change from one color to another. This change can be irreversible or reversible. Each thermochromic colorant has a fixed temperature range over which its color change takes place, and this temperature range is called activation temperature or activation point. Here we can see the thermochromic inks in use. They are especially used in food packaging industry, in beverage industry, where they can point out when the drink is ready to be consumed. Leucodye-based inks consist of encapsulated three-part system. There is a dye that changes color. There is a color developer and a solvent. At temperatures below activation point, the solvent is in solid state, enabling the dye and the color developer to form a color, which we see as a full color effect. When temperature reaches the activation point, the solvent becomes liquid, keeping color developer and the leucodye apart. What we see as the ink loses its color or becomes translucent. Since these colorants in thermochromic inks are micro-encapsulated, the prints obtained with them are more sensitive to abrasion in comparison to conventional prints. And they are also very sensitive to adverse environmental conditions, exposure to UV light, heat, and certain chemicals and solvents. So this was idea for us to check mechanical and chemical resistance of UV-cured thermochromic inks applied on metallized label papers. The prints were subjected to a standard rub test, and they were also treated with 3 liquid agents to prove prints resistance to those liquids and chemicals. The degree of rubbing was assessed by visual inspection. We checked for ink transfer onto the white paper against the print was rubbed, and we also detected the colorimetric changes on the prints after their exposure to rubbing. And very similar chemical resistance of prints was assessed by visual inspection. We checked for bleeding of the colorants into the receptor and by detection of colorimetric changes on the prints after their exposure to those liquid agents. So for printing, we have chosen 2 metallized label papers which differed in the surface properties. One was glossy, radiant, and another was embossed. Here are their properties. They were of same basis weight, very similar thickness, and they had a functional coating on the reverse side, so this smoothness back and curl values are referred to the reverse side. We have chosen 2 commercially available thermochromic UV screenings from the same producer. Both things were reversible, and first one was colored in orange below its activation point, which was set to 12 degrees Celsius, and when warm, it changed to yellow. Second ink was colored in purple below its activation point, which was set to 31 degrees Celsius, and changed to pink above it. So I named these inks orange yellow and purple pink. In order to transfer from one color to another, they had to contain two types of colorants. They had thermochromic leucodyes mixed with conventional pigments. Printing was conducted in a laboratory conditions by semi-automatic screen printing device. We printed the prints in full tone, and of course they were cured in a UV dryer. For rub test trials, we used our Hanatec rub and abrasion tester. The dry print was rubbed against one white uncoated paper in the same plane at the same speed and under constant pressures. But we had two test conditions. We varied the pressures. We had first pressure was 3.6 kilopascals and another was 6.9, and number of rubs was set to 50 for each tested sample. Regarding assessment of prints resistant to liquid agents, we used three test agents. We used distilled water, ethanol, and citric acid to simulate water, alcohol, and juice of citrus fruits. For assessment of prints resistant to those liquid agents, the printed sample was brought into contact with filter papers previously saturated with the test fluid, distilled water, or citric acid, and then they were placed under a load of 1 kilogram for a certain time. The test duration for water was 24 hours, and for citric acid, it was set to 1 hour. After that, the prints were dried in an oven. And also for the method of testing resistance of prints to ethanol, this was performed in a test tube, which was half filled with ethanol, and the printed sample was submerged in it. The contact time was only 5 minutes, and after that, the print was also dried. The assessment of the print's resistance to those liquid agents was done by inspecting any changes in the prints, in the color of the prints, and in the receptor. We checked for bleeding of the colorants onto the photo paper or in the testing solvent. So here are the results of rub-resistant measurements. As I mentioned before, we first checked visually if any transference of ink happened to the white uncoated paper against which the print was rubbed, and we did not see any transference. So we can conclude that the printed samples had high rub resistance. But we also checked, of course, we calculated the color difference parameter, delta E 2000, and for both inks applied on both substrates. And from the results here, you can clearly see that both tested inks under all testing conditions showed minimal optical changes, as all measured differences were below 2, which is considered as an acceptable color difference. As regard of prints chemical resistance, we first checked for bleeding of the colorants in the filter paper or testing solvent. After treatment with water, for both tested label papers, a moderate bleeding was noticed in case of purple-pink prints, but in case of orange-yellow prints, no bleeding was detected. But after treatment with ethanol, we noticed severe bleeding from both tested inks. And you can see now from these pictures that exposure to ethanol caused severe damage to the prints. At some parts, prints were peeled off from the substrate, which means that the ethanol as a strong solvent ruined the adhesion of the ink onto the substrate. And high discoloration is also noticeable. After treatment with citric acid, for both tested label papers, quite high bleeding of colorants into the filter papers was detected in case of purple-pink inks, while only a slight indication of bleeding was detected from orange-yellow ink printed on glossy label paper. And when we checked the ink printed on embossed label paper, we did not notice any bleeding. onto the receptor. And here are determination of color differences CA delta E 2000 on orange-yellow ink. We did the spectrophotometric measurements at 2 fixed temperatures for each print substrate combination, one below its activation point and another above its activation point. So on the left, you can see the results of the color difference when the print was in a cold state, when thermochromic colorants are active. And on the right, you can see results that we got when ink was warmed above its activation point. So if we compare those results, we see the highest color differences, noticed when prints were in their cold state, which we thought we will get. And we can see that all liquid agents have affected the prints, since these results are quite high and they are unacceptable. When we and ethanol, of course, as a strong solvent, degraded the prints at the highest extent. When we look at the results obtained on another ink, we can see the similar trend. Of course, greater effect of all liquids agents on the prints can be observed when the thermochromic microcapsules are active. But when we compare all the results all together, we can see that the prints made with orange-yellow ink were affected more by selected liquid agents than those printed with purple-pink ink. Also, when we compare these results from the aspect of the printing substrate, inks printed on the embossed metallized substrate in most cases were slightly less resistant to liquid chemical agents. It is maybe possible that on this rougher surface where ink deposited adheres to the irregularities of embossed surface, the change in color caused by these liquid agents becomes more prominent than on smoother surface where ink is deposited in more uniform layer. Here you can see the spectroreflectant curves for both inks printed on both substrates. Maybe I can enlarge this like this. So you can see the reflectant curves before and after treatment with ethanol, with citric acid, and with water. What is seen is that the degradation on orange-yellow ink is higher on both substrates than on purple-pink ink, indicating the poorer stability of orange-yellow ink, which is very much in line with the measured delta E 2000 values. So to conclude this research, thermochromic UV cured inks showed good rub resistance, as no rub was detected either by visual inspection or by spectrophotometric evaluation of colorimetric changes of the prints. All tested prints showed low resistance to liquid chemical agents, especially to the ethanol, which degraded the prints at the highest extent. Higher bleeding of colorants was visually inspected from purple-pink prints than from orange-yellow prints, while at the same time the spectrophotometric evaluation showed that prints made with orange-yellow inks had a lower resistance to all liquid agents in comparison to pink-purple prints. Highest color differences were noticed when prints were in their cold state, that is when thermochromic microcapsules were active. And the metallized label paper with a rougher surface was slightly more affected by the liquid agents than one with a smoother and more radiant surface. And very important that which I forgot to say, even though the prints were not able to completely withstand exposure to those liquid agents, the thermochromic effect was still present in them after these tests were conducted. So the inks, even though they were degraded, they were able to still change their color when heated. So this thermochromic effect was still present. So I thank you very much for your attention. This is all from me.